This video summarizes the calorimetry calculations that were discussed in class and is going to be especially helpful for those of you who are absent. I also encourage you to get the notes from a friend with specific examples that we discussed in class. So, in general, the most important calorimetry calculation that gets used is, I just have to get my pen here, the heat of a substance, or the amount, the number of calories given off by a substance or absorbed by a substance, can be calculated if you have the mass of the substance, the specific heat of the substance, and also a temperature change that had occurred with a reaction or anything that may cause a temperature change. The symbol for heat is Q. The symbol for mass is M. Specific heat has a symbol of C with a little subscript P. And this delta symbol is the classic symbol for change, the same sort of symbol you'd see with a slope calculation, the change in y over the change in x. So this means the temperature change. The units that heat are measured in, include calories and joules. And the units for mass is grams, and specific heat is a number that is unique to every single substance. And each substance has its own unique specific heat. The units are calories per gram per degree Celsius or joules per gram per degree Celsius. And it all depends on what sort of unit of heat you're using, if it's calories or joules. So a recap of what we did in the snack burning lab. We took a burning snack, and I encourage you to watch a demonstration of what was done in the chemistry lab. It's a video that I posted onto our classroom site at the time of this recording. It is Neo. So a recap, we took a burning snack and this is the burning snack, and the flames were given off, and we had in a calorimeter, which was a can, hanging. We had some water, and we were taking the temperature of that. And this is a horrible, horrible diagram. That's supposed to be a thermometer. The heat released from the burning snack was absorbed by the water. So the types of measurements we took in the lab included the temperature of the water before and after the snack burned. Also, we ended up taking the mass of the snack before burning and the mass of the snack after burning. So before putting the water into the aluminum can, which is our calorimeter, we took the mass of the water. So here's the scenario. A burning cashew caused the temperature of 106 grams of water. So our mass of our water is 101.6. I think I made a mistake when I said that before, 101.6, to increase from 22.2 degrees Celsius. So we have an initial temperature of 22.2, and after the snack burns, a final temperature of 30.1 degrees Celsius. So since the energy is being transferred to the water, we can assume that any heat given off by the snack is being transferred to the water, which again is kind of a bad assumption because there are lots of places heat can escape in this scenario. With true calorimetry, a device is built to make sure that all of the energy being given off by whatever is being burned is being transferred to the substance that is being used to indirectly get to the number of calories or the amount of heat. So since we had water in the calorimeter, we know that the specific heat of water is 1.0 calories per gram per degree Celsius. The question is, how much heat was released by the burning cashew? So this is the calculation. The heat equals since we're talking about the amount of water, the amount of heat absorbed by the water, we have water information in the calculation. So the heat is the mass of the water times the specific heat of water times the temperature change. So in this case, the mass of the water is 101.6 grams. The specific heat of the water we know to be 1.00 calorie per gram per degree Celsius. The change in temperature of the water is going to be your final temperature, 30.1 degrees Celsius minus 22.2 degrees Celsius, which gives us 7.9. So when we plug these numbers into that calculation, Q, or heat, which is going to be in calories, is 101.6 grams times 100, or 1.00 calorie per gram per degree Celsius times 7.9 degrees Celsius. Now, when we do this calculation, we do have some unit cancellation. Grams is on the top here and on the bottom here. Since it's calorie per gram per degree Celsius, the grams units cancels. Degrees Celsius is here on the bottom as well, and since it's on the top here, degrees Celsius cancels, which leaves your answer in calories. When you plug those numbers into the calculator says 802.64 calories. Now, with this, we have to follow the rules of significant figures. This is a multiplication problem, and this measurement has 4 significant figures, whereas this measurement has 2 significant figures. When you have specific numbers that are constants or they're known values, like specific heat, that is not taken into consideration when looking at sig figs. You have to look at the measurements. So with multiplication, the measurement with the fewest significant figures, which is this one right here, will determine how many sig figs the final answer will have. Now, it's really hard to round 802.64 calories into 2 sig figs, and the only way you can possibly do it is to turn this into scientific notation. So that becomes 8.0 times 10 to the second power calories. So when the snack was burned, it gave off approximately 800 calories in that reaction. Now, another thing that was taken into account was the mass of the snack burned. So some people had bigger cashews and some had smaller cashews. So if we're going to compare apples to apples, we have to figure out how much of the snack burned and the calories per gram. So the next set of slides will bring us into a discussion that addresses that. So in the same reaction, the initial mass of the snack system was 18.08 grams. After burning the cashew, I'm going to turn my pen on here. After burning the cashew, the mass was 17.69 grams. How many grams of the snack were burned? To get the mass of the snack burned, we have to take the initial mass of the whole system, and I'm just going to remind you that the system in this case was a little pedestal, and on the pedestal was a little wire clip, and then we had the cashew stuck there. So this whole thing was measured before burning and after burning. When you get the difference of the whole system before and after burning, you can actually calculate the amount of the number of grams of cashew burned, which is 0.39 grams. So how can this information be used and be helpful? We can use the calculation from before, the number of calories, and figure out how many calories per gram were burned, knowing that we only burned 0.39 grams. So this calculation is going to be shown on the next slide. And here's the question. How many calories? I'm turning my pen on again. how many calories per gram were released by the cashew in this trial? So we already calculated that the calories released is 8 times 10 to the second, 8.0 times 10 to the second calories, which is about 800. We know that the mass of the snack burned is 0.39 grams. So to get calories per gram, we actually take 8.0 times 10 to the second power calories divided by 0.39 grams. So 800 divided by 800 calories divided by 0.39. This is my chicken scratch here. It's kind of hard. Grams gives, the calculator gives us 2,058.05 calories per gram. Now we have to use the rules of significant figure. We have to use the rules of significant figures here. Even though I didn't write it out like that, our original measurement here has 2 sig figs, and this one also has 2 sig figs. So we need to round this to 2 sig figs, which would round it to 2,100 calories per gram for this snack burned. Now that seems like a lot of calories, 2,100 calories per gram. But what you have to remember is that when we're talking about chemistry calories, it's not the same as food calories. So 1 food calorie, and that's typically capitalized, is equivalent to 1,000 chemistry calories. So the number of food calories is actually only 2.1. If we take our 2,100 calories per gram, it's equivalent to 2.1 food calories or kilocalories per gram. Now that seems a little bit more reasonable, that if you take a cashew and it may have a mass of, a half a gram to begin with, that there would only be a couple calories. The calories that we're familiar with are actually kilocalories. I am sorry about the chicken scratch that this pen offers. So that concludes my calorimetry video to show how the calculations are done and the unit cancellation. And from here I am going to make another video that talks about how to use a spreadsheet to do all of these calculations for each trial for you. So that is another video that can be found in the same place as this one. Thanks for watching. See you next time.